Hello, can you hear me? Hello?
Yes, sir.
Oh.
Yes,
Is
sir.
the board visible to you? Is the writing over the board visible to you?
Yes, sir.
Oh. Can you recollect what we discussed in the last class? Can any of you recollect what we discussed in the last class? Respond, please. Respond, please.
Yes, sir. In the last class, we studied about like what are algorithms and time
Algorithms and
complexity.
space time complexity.
Algorithm,
Sir, computational complexity.
algorithms and computational complexity. And in this connection, I discussed the time complexity of linear search algorithm. Can you recollect it? Given
Yes,
a
sir.
list of numbers.
Yes, sir.
Okay. Okay. Now today we will discuss an algorithm to reverse a sequence of numbers. To reverse a sequence of numbers. How it works? Let this be the algorithm. Input to this algorithm will be a sequence of numbers. Let this be 6, 7, 8, 9. What will be the output? Output will be 9, 8, 7, 6. So we want to design an algorithm which will accept the list of some numbers and it will reverse this list of numbers. That means it will display this list of numbers in reverse order. Is this all right? Is the problem clear to you?
Yes, sir.
Okay. So you first tell me, how can we store this list of numbers inside the computer? If it was a single number, we could use a variable to store that number. But it is a list of numbers. So where should we store this number?
We should use an array.
It
Array.
should be stored in an array. Let us name that array as A. So the size of the array is, let the size of the array is n. It is equal to 3 in this case. So what we want to store this number in reverse order in this array. In the same array, we want to store this number in reverse order in the same array.
So how the size is 3?
Pardon?
How the size is 3 in this case?
Let the size of the array equal to n, which is equal to 4, which is equal to 4 in this case.
Yes, sir.
Thank you.
Okay, sir.
So we want to store the number in reverse order in the same array. How we can do this? Let us start. Now, if we reverse the list of numbers in this array, then what will happen? This 6 will ultimately be placed in A3 position and 9 will ultimately be placed in A0 position. If we reverse the numbers in this array, that is like this, 9, 8, 7, 6. So this 6 will appear here and 9 will appear here. 8 will appear here, 7 will appear here. Now, this we cannot do in a single step. To do this, we need to follow a step-by-step operation. That means we will first move 6 from here to here, and as soon as we move 6 from here to here, the 7 will be placed before 6, and it can be illustrated in this way.
Sir, the voice in the video is not clear.
Pardon? Figure is not clear. I cannot hear you. So we will move in step 1, we will move 6 from here to here. And as soon as we move 6 from here to here, the existing element of this A1 position, that is 7, it will be erased. So before moving 6 from 0 to 1th position, we should store 7 somewhere. Let in a variable x, we will store 7, so that it can be restored from x after 6 is moved from here to here. And let us use a variable I that will denote the position where from the left side a number will be moved. And let us begin from the first element of the array. Now after we move 6 here, 7 should follow 6. So we should copy x in this position, and all the other elements in the array, they will remain same as it is. So we will place 7 here. Next time, this I will have value 2. So I will point here and it will have a value 2. And what we will do, we will move from A1, we will move 6 from A1 to A2 and the 7 from A0 to A1. And as soon as we move 6 from A1 to A2, 8 will be erased. So we should store 8 in the variable x. And finally, this 8 should be copied here. And 9 will remain there. Now, in the next step, we will increment the value of I by 1. It will be 3. And this 6 will be moved from here to here. 7 will be moved from here to here. 8 will be moved from here to here, and in this blank space 9 will be stored. And as soon as 6 is moved from here to here, 9 will be erased. So to restore it, we should store 9 in x. Now, can you follow this? Can you follow this illustration? First tell me. Then I shall go for the algorithm. And you should know that finally this list of numbers has been reversed and it has been stored in the same array. Please respond quickly. Please respond. I have many topics to cover. Please cooperate.
Yes, sir.
Okay. So then I am writing the algorithm for this. That is the necessary steps of operations. and I am writing it in a C-like language. You could also write it in any way you want, because it is an algorithm. We will not feed it into the computer for execution. We only want to show the basic elementary steps of operations which should be followed for this purpose. So here I will be varied from 1 to n in steps of 1. And before copying the element a I minus 1 into a ith position, it should be first preserved in some variable x. Then this aj, it will have a value I. So initially at a ith position, element from a I minus 1th position will be copied. And how long this copy will be continued? In steps of 1, and so long j is greater than equal to 1. And after copying all elements, the 0th position in the array that will be blank, and this x will be copied in a 0th position. And in this way, when this inner loop, red loop, will be executed for all values of I from 1 to n minus 1, 1 to n minus 1, is I is not less than n, but I is less than equal to n. It should be less than equal to n. I equal to here dot 10 less than n. I actually it will be less than equal to n minus 1. Less than equal to right in this way. Or we can also write I less than n. We can also write up to I less than n. It is all the same. Okay, now you tell me whether you can follow this algorithm.
Yes, sir.
Okay. Then I shall try to find the time complexity of this algorithm. Let us try to find the time complexity of this algorithm. What is the time complexity? Time complexity for an algorithm is an exact representation, exact functional representation of the time that the algorithm will take with a given input size. With a given input size. Here, what is the input size here? The number of elements in the list. That is n is the input size here. It will be total number of copy operation. বলো তো আচ্ছা for I equal to 1 this this a0 will be copied into a1 only one. So one copy operation will be required for I equal to 1. All right.
Yes, sir.
So I have written 1 here. I is incremented by 1. Next time I will have a value 2. Then a1 will be copied into a2 and a0 will be copied into a1. So how many copy operations will be performed for I equal to 2? 2 copy operations will be performed. And finally, for I equal to n minus 1, that is for the last element of the array, n minus 1 number of copy operations will be performed. And we need to sum all these copy operations to compute the total number of copy operations.
Yes, sir. Yes, sir.
Okay. And it is an AP series. So we can easily compute this sum. This sum is Do you agree with this time complexity? Do you agree?
Yes, sir.
Okay. Now here we have obtained a time complexity which is represented by a polynomial of degree 2. Here we have obtained a time complexity which is represented by a polynomial of degree 2. Now we can write the same algorithm, sorry, we can write another alternative algorithm for the same problem with a time complexity, with a linear time complexity, with a linear time complexity. And how, that I am going to explain before you. Let us consider another alternative algorithm for the same problem. It may not be possible always that for the same problem we may have different alternative algorithms. But for this problem, it happens to be that there are more than one algorithms with different order of complexities that I am going to explain. Do you know? Do you know how to swap two elements AI and AJ? Do you know how to swap these two elements AI and AJ? Do you know the meaning of swapping the two elements in an array?
Interchanging the value, sir.
Interchanging the value. So how we can interchange this value? If I directly assign AJ to AI, what will happen? The original content of AI will be lost and we cannot get it back. So before doing this, what I should write? I should store this AI in some temporary location in some temporary location T. I can store this here. And after that, I can copy AJ to AI. And if the original content of AI is lost after this copy operation, no problem, that is already stored in T. So then the content of T will be copied to AJ. So these are the three operations which are necessary for swapping the elements of AI and AJ in an array A. Do you agree?
Yes. Yes, sir.
Okay. Now, by this swapping operation, we can do the same thing over the list of numbers. We can also reverse the numbers, list of numbers by using this swapping operation. How? I am going to illustrate. Choice of So in this way, through pairwise swapping, we can reverse the elements of the array A. Agreed?
Yes, sir.
Okay. Then what will be the algorithm for this? Let me write an algorithm for this. So this will be the algorithm. This is an alternative version. This is an alternative version of the algorithm for swapping two numbers.
Sir, I will be less than 2, right? Less than n by 2.
I is so long I is greater than right. It should be less than n by 2. I is starting. Yes, so long I is. Thank you. So long I is less than n by 2. Alright. Actually, I is increasing from 0, 1, and as soon as it will be equal to n by 2, this will come out of loop. Okay, thank you. So, is this the algorithm for swapping? Sorry, for reversing the numbers? For reversing the numbers in an array?
Yes, sir.
Okay, acha. Now, what is the major operation? What is the operation that will consume the major portion of the execution time of this algorithm? This is swapping operation. Do you agree with this algorithm?
Yes, sir.
So, what will be the complexity of this algorithm? The time complexity of this algorithm will be Tn will be n by 2, where n is the size of the input, that is the size of the array. Agreed?
Akbar, sir. Akbar.
Time complexity of this algorithm. That is, we want to have a functional representation of the time that this algorithm will take to complete all operation, and that time must be expressed in term of the input size. What is the input size? Input size is n. That is the longer will be the length of the list of numbers, the longer will be the length of the array, the higher will be the execution time for this algorithm.
Yes, sir.
Agreed? Now let us assume that n be the length of the array, or n be the list, n be the length of the list of the numbers, and we are assuming that each swap operation requires 1 unit of time. Each swap operation requires 1 unit of time. Now, how many swap operations are to be performed? For I equal to 0, 1 swap operation will be performed. For I equal to 1, 1 swap operation will be performed. In this way, for I equal to n by 2, that is I equal to n by 2 minus 1, 1 operation will be performed. Right?
Yes, sir.
So how many swap operation will be performed? N by 2 number of swap operation will be performed to reverse the elements of this array. So this will be the time complexity of this algorithm.
Yes, sir.
Now this function represents an equation to a straight line, that is half into n plus 0. It represents half into n plus 0. That means if you plot it here, you will have a line passing through the origin. That means if you increase the value of n, the value of Tn will increase proportionally. Agreed?
Yes, sir.
Okay. Now, in case of the previous version of the same algorithm, it will be function will be like this, because there the function was a polynomial of degree 2, that is n square by 2 minus n by 2. It was a polynomial of degree 2. So here the rate of growth of this function will be much higher than this function. That means if you plot them over the same this will be like this. The rate of growth of this function will be much higher compared to this. Can you follow this? Respond please. Please respond.
Yes, sir.
Yes, sir. Yes, sir.
Achha. So let us summarize what we have done. We have considered a problem. The problem that asked for an algorithm to reverse the n elements of an array. This was the problem. And for that problem, how many algorithms do we have so far? Tell me. How many algorithms we have so far discussed for this problem?
One.
2 algorithms.
2 algorithms. The first version has a time complexity that is equal to n square by 2 minus n by 2, and the second version It is another alternative algorithm. This alternative algorithm has a time complexity of n by 2. So from this, what we can conclude that for the same for the same problem, we may have several algorithms. For the same problem, sometimes we may have more than one algorithm. Agreed?
Yes, sir.
But but all may not be of equal complexities. All may not be of equal time and or space complexities. Now, let us think of in some other way. As if we have two machines, M1 and M2, for doing the same task. Out of these two machines, which one will be called efficient? The
So the
machine,
machine.
the machine that requires less energy for doing the same amount of work, that will be called more efficient. And the machine that requires higher energy for doing the same amount of job, that will be called less efficient. Isn't it?
Yes, sir.
Okay. Now, in this case, for the same problem, we have two algorithms. The rate of growth of the time complexity of one algorithm is much faster than the rate of growth of the time complexity of the other algorithm. The rate of growth of the time complexity of one algorithm is much faster than the rate of growth of the time complexity of the other algorithm. Now, out of these two algorithms, which one we should prefer?
Second one.
The second one.
Red one. Red one. Red one.
No, sir. No, sir.
Which one?
Sir,
Black one.
যেটা লিনিয়ারি টাইমটাকে ভেরি করছে সেটা।
Because for the same input size, just 1 minute. Because for the same input size, this algorithm will require this much of time, and this algorithm will require higher amount of time. For the same algorithm, this algorithm will require this much of time, and this algorithm will require so much amount of time. So for the same input size, when the input size is sufficiently large, for the same input size, this black colored algorithm, it requires lesser amount of time. Isn't it? So it does the same work with lesser amount of computation. With lesser computation. That's why this black algorithm is preferred over the red version of the algorithm. And this black version of the algorithm will be called more time efficient compared to the red version of the algorithm.
Yes, sir.
Just tell me can we have a class on Monday? Monday we have a scheduled class, isn't it? At 4:30 we have a scheduled class.
Yes, sir.
So I shall continue this topic in the next Monday. Let us stop here today. All right.
All right, sir.
Okay. Next Monday I shall continue. Okay. Bye. I am leaving.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you for your cooperation. Thank you.